So hello everybody. I am happy to see you here. I hope that you are really into database and into data engineering, and I hope these workshops will be very helpful for you. First, I will present myself. My name is Daniela Andranovic. I'm a student at the Technical University of Moldova. This weekend, we will have 4 workshops where we will discuss about database components, about Microsoft SQL Server. We will learn how to create, modify, and delete tables or records from these tables. Also, we will talk about integrity constraints, data types, operators, aggregate functions, and so on. So let's see the content of today's workshop. So we will talk today about what is a database, what is a database management system, types of database management system, structured query language, SQL, what is Microsoft SQL Server. We will talk also about SQL commands, data types, integrity constraints, and operators. Let's us consider a situation when you put all your stationery in a single drawer without organizing it. When you want to take, for example, a scissor, you have to search a lot through the drawer, which consumes you a lot of time. This can be compared to the normal file storage in your system. But if the amount of information is huge, in our case, if we have so many pencils, scissors, erasers, and so on, this becomes inefficient to search through the drawer. Now imagine that you organize your stationery such that all the pens go into the middle section, all the scissors in the left section, stickers in the right, and so on. Now you want to pick a pen, immediately you will search in the middle, those you'll know where to find it efficiently. This can be compared to the relational model of storage. Every organization has some information needs. A library keeps the list of the members, books, due dates, and fines in case that someone forgot to give back the book. A company needs to save information about its employees, departments, and salaries. These pieces of information are called data. Organizations can store data in various media and in different formats. Let's say they store the data in some documents in, I don't know, in a cabinet, or stored in electronic spreadsheets or in databases. Database is an organized collection of information. To manage databases, you need a database management system, which we'll discuss what's it in the current slide. So a database management system, you will hear this word very often used today and tomorrow, at least in my workshops, is a program that stores, retrieves, and modifies data in database on request. It serves as an interface between the database and the final user or their programs, allowing the user to retrieve, update, and manage how information is organized and optimized. It ensures minimized data processing, reduce response time, flexibility, high protection, and so on. Through such a system, you will be able to check the progress, backup, and even recover data. Let's see some popular software. The most popular database software is Microsoft Access, MySQL, ProgressSQL, Microsoft SQL Server, Oracle Database, SQLite, and DBase, and there are many others, but these are the most, let's say, famous. The main tasks of the database management systems are to organize the data. Data is organized or structured in the manner most suitable to each application. To integrate data are interrelated or linked together, and it can be assembled in many combinations during execution of a particular application problem. The database management system is the vehicle used to collect, combine, and return a portion of the available data to the user. To protect the data, security is a very important feature. A database management system protects and secures both the content of a database and the relationships of data elements. Data are protected against access by unauthorized users, physical damage, operating system failure, simultaneous updating, and certain interruptions initiated by a host program. Current access means access at the same time to the same collection of data by multiple customers and recover data. In a recovery operation, database management system provides a recovery platform with the necessary tools to fully or partially restore database to their previous state. There are four main types of database: hierarchical, network, relational, and object-oriented database. Let's talk briefly about each one in part. Hierarchical database is the type of database that stores data in form of parent, and child relationship nodes. Here it organizes data in tree-like structure, as you can see, and maybe you know from the data structures course. It seems like a tree. Each child record in the tree will contain only one parent. On the other hand, each parent record can have multiple childs. Here, produce has two childs, but fruit has only one parent. This model is specific to the 16th and 17th year. The network database follows the network data model. Here, the representation of the data is in the form of nodes connected via links between them. Unlike the hierarchical database, it allows each record to have multiple children and parent nodes to form a generalized graph structure. So if we compare hierarchical database with network database, here we can see that, for example, organic has one parent, but let's say lemons has as parent organic and non-organic. So here the lemons have only one parent, but here they have it has two parents. Moving next to relational database, because the hierarchical and the network database models were file oriented, was created a relational database which was oriented on sets. So the relational database is based on a relational data model, which stores data in form of rows called tuples and columns called attributes. So you have to remember these terms. We will use the rows and columns, but actually they are called tuples and attributes. And the tables here are called relation. A relational database uses SQL for storing, manipulating, as well as maintaining the data. Edgar Frank Code invented the relational database in 1970. Each table in the database carries a key. Here in the presentation, you can see some keys with yellow. These keys make the data unique from others. Example of relational database are, as I said in the previous slide, the MySQL, Microsoft SQL Server, Oracle, and so on. And moving next to object-oriented database is a type of database that uses the object-based data model approach for storing data in the database system. The data is represented and stored as objects, which are similar to the objects from object-oriented programming. Maybe you know about object-oriented programming, so this is the main idea. Let's go next and see what is SQL. Structured query language is a language designed entirely for accessing database. SQL is used to communicate with database according to ANSI, American National Standards Institute. It is the standard language for relational database management system. SQL statements are used to perform tasks such as update the data on a database, to retrieve data from a database. Some common relational database management systems that use SQL are, again, Oracle, Base, Microsoft SQL Server, and Microsoft Access, and so on. Although most database systems use SQL, most of them also have their own traditional proprietary extensions that are usually only used on their system. For example, in Microsoft SQL Server, there is Transact SQL. It's, let's say, a specific SQL only for Microsoft SQL Server. Some SQL standard commands are select, insert, update, delete, create, and drop. And they can be used to accomplish almost everything that you need to do with a database. We talk so much about Microsoft SQL Server, but let's see what it is, this software, and which features it has. Until now, I have mentioned SQL Server not only once. So Microsoft SQL Server is a relational database management system developed by Microsoft, obviously. The first version was launched in 1989. The first language used by this system was SQL, the one we talked in the previous slide. This database management system becomes very suitable for a variety of projects, from small applications to large projects. It is well known that Microsoft SQL Server has been for long a database management system only for Windows, but starting with the 17th version, it is also available on Linux. Microsoft SQL Server comes with its own implementation of SQL language, as I mentioned, which is Transact SQL. It has integrated environment for SQL database management, which is SQL Server Management Studio. You had to download this SQL Server Management Studio. About installation, we'll talk about a bit later. Microsoft provides several editions depending on the user needs. A standard edition, which includes the core functionality required for most application. Enterprise edition, unlike the standard one, adds support for more users, databases, and transactions. It includes other advanced features, and it is a perfect choice for big organizations. The developer edition is designed for developers who need to create applications, products that will run on top of SQL Server. Actually, it contains all the functionality of the Enterprise Edition, but it is licensed for use as a development and test system, not in production. And the Express edition is the most limited edition of SQL Server. It is only used by individuals or small organizations. It is the most accessible edition, but it also the least functional because it has limited functionality. So about installation, did you manage to install Microsoft SQL Server and to connect it through the SQL Server Management Studio? We will use Microsoft SQL Server Management Studio in the at the following workshop. So it is very simple. I install Microsoft SQL Server, then connect to Microsoft SQL Server Management Studio and access the database engine. SQL commands are instructions used to communicate with database, perform specific tasks, functions, and queries of data. There are 5 types of SQL commands. Data definition language is used to create and modify the structure of a database, objects in a database, like creating a table, deleting a table, altering a table, and so on. Data manipulation language is, let's say, the commands that allow you to manipulate data in a database. This manipulation involves inserting data into a table, deleting the data, and modify the data. The data control language is used to control user access in a database. This command is related to the security issues. Using data command language, it allows or restricts the user from accessing data in database schema. Transact control language is used to manage the changes made by DML. So with the help of transactions, you can control what you manage to do on your data. And the data query language is used to fetch, retrieve, or obtain, call it how you want. Okay, you can obtain the data from a table. During the next workshops, we will analyze more data definition language, data manipulation language, and data query language. Let's move next to data types. When we talk about data types, we mean that what kind of data we can store in our database. The entire column, and how I said that column is called attribute, of a table must respect the data type specified for this column. This specification is made when you create a table. Data types in the SQL Server are organized in the following categories: exact numeric, approximate numeric, date and time, character strings, Unicode character strings, binary strings, and other, where this other is called also specific data types. Now let's see each one in part and to understand much better this information. So exact numeric data are data types that stores exact numeric as integer, decimal, or monetary amount. Some examples are big int, int, small int, tiny int, bit, decimal, numeric, money, and small money. Moving next to approximate numeric, as the name can tell to you, that approximate numeric data type stores floating point numeric data. They are often used in scientific calculations. So here you have only float and real. And at the float, you can specify the length of a floating point in the brackets. Character strings are data types that allow you to store either fixed length char or variable length char. For fixed length, you have char. For variable length, you have bar char, and the text data type. Moving next to date and time. The date and time, as it can tell to you the name, is the data types that allows you to store data and time, and the date time offset. Offset is the difference between the current date and the time at the coordinated universal time, UTCs in short. So here we have date and time, small date and time, date time offset, date time too. I know it's a lot of information for you now, but I think this information on the slides will be helpful maybe in the future for you, in case you'll be interested in a database. Let's move next to Unicode character strings. Unicode character string data types store either fixed length, here we have nchar, or variable length, nvarchar, Unicode character data. Unicode is a universal character encoding standard that assigns a code to every character and symbol in every language in the world. Since no other encoding standard supports a language, Unicode is the only encoding standard that ensures that you can retrieve or combine data using any combination of languages. So as I said, here we have nchar, nvarchar, and ntext. The next one is a binary string. The binary strings data type stores fixed and variable length binary data. For fixed, we have binary. For variable length, we have var binary. And also the images are stored with this data type. Let's go next to the other data types. They're more exotic. Let's say here we have cursor, row version, hierarchy ID, unique identifier, SQL variant, XML, spatial geometry type, spatial geography type, and table. I wouldn't mention what they're doing, just I present to you what special data types we have in Microsoft SQL Server. In case you'll be interested, maybe you'll inform yourself about them. Let's go next with data type precedence. Data type precedence is the set of rules that SQL Server uses when a calculation or combination is specified for two or more expressions that have different data types. Data type precedence is also used to optimizing indexes of different data types. In this situation, SQL Server uses an established priority or precedence of data types. The data type with the lower precedence is converted to the data type with higher precedence. This is referred to an implicit conversion. So here we have the highest precision, and moving one by one, we go to lower and lower and lower precedence. So if we have, for example, an int and a float in some calculations, this int will be converted automatically in the float, and the calculations will be performed, and so on. So I think that's it with the data precedence. Let's move next to data definition language, data manipulation language, and data query language. Okay, this one I will mention that we will focus only on this one on the next workshops. Integrity constraints. So integrity constraints are the protocols, and protocols are the set of rules that the tables data columns must follow. These are used to restrict the data types of information that can be entered in the table. This means that the data in the database is accurate and reliable. You may apply integrity constraints at the column or table level. The table level integrity constraints apply to the entire table, while the column level constraints are applied only to one column. If integrity constraints are not respected, the database is said to be inconsistent. There are 6 types of integrity constraints supported by SQL Server. Let's say it is not null. Not null constraint prevents a column for having null values. The unique constraints ensures that any value in a column is unique and accepts only, and it also accepts null values. The primary key. The primary key, it's an interesting constraint. Let's say it's a field in a database table that uniquely identifies each row, each record. Primary keys must have distinct values. Null values are not allowed in a primary key column. A table can have only one primary key, but the primary key can consist of one or more columns. It creates a composite key that several fields are used as a primary key. So we can have only one primary key in a table, but this primary key can consist from one or more columns. The foreign key is a column or a set of columns corresponding to the primary key of another table. the primary key is used to define relationships between tables. For example, we have a table student, which contains information about students, including the ID, which is the primary key. Usually the ID is the primary, and foreign key, the ID is always the key. So we have a table student with the ID, with the name, with the date of birth, and so on. We have another table called student grade, which has the following columns: ID, student ID, and mark. So the column student ID from the second table is linked to the ID from the student table. Therefore, student ID is a foreign key for the ID from the student table. It should be mentioned that when inserting a new record in the student grade, which has a foreign key to the first table, the value of a column which is a foreign key must exist in the second table, which is linked. It means that we must have a student with the specified ID. So maybe it is a bit confusing, this information, but in practice you will understand more. I think in the next week when you will study the joins. So I will talk about check constraint. This check constraint limits a value range that can be placed in a column. When updating the database table, the system tests the Boolean constraint specified after the word check. If it is true, the update is accepted, otherwise rejected. For example, you can define a constraint on the table of marks, let's say, and the mark is valid if it's greater than 0. This will be done if we write check, mark, the greater sign, and 0. This is how it is implemented. And moving to the last integrity constraint is the default. Default, when no value is defined for a column, the default constraint provides a default value. Getting back to our student table, if there is a column called country, let's say, and if we insert a new record in this table without mentioning the country, but by default we establish that it will be Moldova, let's say, it automatically inserts Moldova in the country column. So let's go next to the operators. In the construction of SQL statements, it is common to use various expressions and operators. Two expressions may be combined with an operator if both have data types supported by the operator and meet at least one of the following conditions. Expressions have the same data type, the lower priority data type can be converted to higher priority. This is done with the data type precedence, which I showed before. The operators used in construct and transact SQL expressions can be classified as arithmetic, comparison, logical operators, character, and bitwise operator. So let's discover each operator, each type of operator. So we have arithmetic operators. This is the traditional addition, subtractions, multiplication, division, and modulo. You know, addition adds two numbers, let's say floating point or exact numeric, doesn't matter. Subtracting the same, multiplication multiplies, division divides, and modulo it's the rest of division. You are familiar with it, I think. Moving next to comparison, we have equal to, greater than or equal to, less than or equal to, not equal. So not equal, we have actually two representations. You choose which one you would like to use. They are not wrong. They're both supported in Microsoft SQL Server. The main difference is that this one is not they're not supported, but it's not, it doesn't respect some standards, and more often it's used this one. But you can choose which one you would like to use. They both work. And we have also not greater than and not less than, which can be, let's say, they can be substituted with one of these. Moving next to our logical operators, we have all. The all is true if all the subquery values meet the conditions. We have and. Maybe you are familiar with bitwise and, when both, let's say, both are true, then it meets the condition and it's true. In other cases, if only one from that operand is false, then it's false. So it's true if all the conditions separated by and is true. Any, it's, let's say, it's not so strict. It's true if any of the subquery values meet the conditions. Between, it's true if the operand is within the range of comparisons. Between gives you the opportunity to indicate a range of values. So we will examine these operators in the next workshop. We have the operator exists. It's true if the subquery returns one or more records. It's true if the operand is equal to one of a list of expressions. We have like. Like is true if the operand matches a pattern. About like operator, we will talk more about. We'll talk more bit later. We have the not operator, which is the negation. We have or with it's true if any of the conditions separated by or is true. As I mentioned, or and are, if you are familiar with bit operations, for you will be easy to do this operator. So we have sum is true if any of the subquery values meet the condition. We have concatenation. Concatenation, it's the unification, let's say, of two or more strings. So you can concatenate, you can unify. So here I don't have much to say. It's an operation for strings. Bitwise, yes, I think you're familiar. We have here and, we have not, we have the or, and we have the bitwise exclusive or. We won't use them so much. I don't know if they are so used, but they exist, and I think you have to know about them. Moving next to like operator. So the like operator is an interesting operator. Here we have the like operator, and we mention the pattern which one we would use. So in case you would like to mention one character, you use the underscore. So if you write, I would like to show all the names which are of length 5, you can mention 5 underscores, for example. The percent gives you the meaning of 0, 1, or multiple characters. Let's say it's a variable length. If you'd like to show all the names which starts with A and doesn't matter the length, it's enough to write A and %. So the query will look like this, like select the names from table names for table students, where the first name, let's say it's the first name like A%. So it will give you all the names which start with A. Also, you can mention the list of characters. You can mention the list A, B, C, D, and so on. And for example, before it a %, so it will give you all the names which will end in A, B, C, D, and which will end in this list of letters. Also, in order to make this list shorter, for example, if we have here A, B, C, D, E, we would like to write it much shorter. It will be A hyphen E, but the list is also used in case you have, for example, only vowels, only some letter specific. Range is much easier because we have a variety of characters. And in case we have a negation, for example, we want to show the names which doesn't really end in this list, for example, doesn't end in AB, we mention this this symbol. So like operator, it's a very interesting one. We will study it more at the following workshops. Also, you have some homework with it. It's an interesting one. You can play with strings a lot with it. So, as I mentioned, underscore is a one single character. The % is 0, 1, or multiple characters. The list can be presented like this, the range with a hyphen, and the negation with the following symbol. And also here we have a precedence, like in the data types, we have a precedence. The most strict and the most important, the first one which will be executed, is the bitwise not. Moving next, we have the multiplication, division, and modulo. Next will be the addition, the subtractions, the concatenation, then bitwise and the bitwise NOR, XOR, and the OR. After it, we will proceed to the comparison operators: equal, less, greater, equal or equal, greater or equal, less than equal, not equal again, not greater, and not less. Next, we will follow the not operator. Then we will look for and after not or and, we have all, any, between, in, like, or some. As you can see, like in bitwise, we will have the first bitwise not, then the bitwise and XOR and OR. Here is the same. We have the not, then the and after it OR, in, all, and all the operators. And the last one is assignment. We haven't mentioned the assignment. We won't use the assignment, but it's the less priority operator. And I think that's it for today. A short introduction in Microsoft SQL Server.